Hi, in the last session, we understand the need of 5G technology and its advancements, and we also talked about the variety of use cases which are planned to serve by 5G technology. Now, in this session, we will be briefly talking about the 5G systems and control plane and user plane and curves in 5G. Okay, so before reaching to 5G, we should see that how 3G and 4G systems was look like, and then we will compare that in brief with the 5G systems. So this is how the 3G systems looks like. 3G systems had three main sections. The user equipment or UE like smartphones and modems, the radio access network or RAN, which is also known as UTRAN, UTRAN. This is responsible for wireless access through the components like NodeB and the RNC, radio network controllers. And the last section is core network, which consists of different functions like storage of subscriber data, security, policy management, mobility management, etc. Well, I'm not going deep on these components at the moment. This is just a brief section. Now the 4G system, this also looks similar, like we have user equipment, one radio access network which is called EUTRAN in 4G and it includes g-NodeB, and one core network, this is known as Evolved Packet Core or EPC core. This EPC or Evolved Packet Core also handles similar functions like 3G core but with little more advanced capabilities. Now continuing the trend, the 5G network also consists of user equipment, the radio access network and the core network. The 5G user equipment includes 5G enabled smartphones, laptops, tablets, modems, Internet of Things devices and even 5G routers for fixed wireless access. The 5G radio access network or 5G RAN includes g-NodeB, which supports the new radio interface called NR. In some cases, you might also see ng-NodeB, which supports both NR and LTE technology. The 5G core network has the functions like storing subscriber data, mobility management, session management, etc. The defining aspect of the 5G core is that in 5G core, there is a clear separation of control plane and user plane functions, and that allows more efficient and flexible network operations. The 5G core is designed with the modern software technologies, including service-based architecture and network virtualization, which make the network more adaptable and scalable. So as mentioned, separation of control plane and the user plane is the one of the key principles of 5G architecture. So what is this control plane and user plane separation? Let's understand this with one example. Consider in some 5G use cases like massive machine type communications, there are many devices that sends a small amount of data. When these devices are dominating in some network area, then there is a need to scale the control signaling infrastructure to handle them efficiently. On the other hand, we have mobile broadband devices, and these devices create a large demand of user plane functions compared to the control signals because this handles more data flow. And if these devices are more common in some network, then the user plane need to be scaled up rather than the control signaling. So if there is no separation of control plane and user plane functions, we would have to scale both functions together, even if only one of them needs it. And this would be an inefficient way of integration because it may create the wastage of network resources. By separating the control plane and user plane, we can scale each one based on the network's specific need. Separating control plane and user plane also helps achieving the lower latency, which is crucial for 5G applications. This is the diagram of 4G system. So you can see that 4G system with the indication of control plane and user plane traffic. You can see that the control plane traffic marked in green and the user plane traffic is in orange. In the 4G system at the top, both the serving gateway and packet gateway handles control plane and user plane functions, means it handles both of these data. But in the 5G core at the bottom architecture, the control plane of serving gateway and packet gateway are combined together with parts of MME to form the session management function shown here as an SMF. The user plane of serving gateway and packet gateway forms the user plane functions, indicated here as UPF. This separation of control plane and user plane functions is known as CUPS, which stands for Control and User Plane Separation. In 5G, the mobility management functions of the MME evolved into the access and mobility management functions, normally called as AMF. The HSS becomes user data management or UDM, and the PCRF turns into the policy control functions or PCF, and all together they form the 5G core. Okay, so that's it for today. In the next session, we will be talking about 5G deployment strategies and options. So stay tuned for the updates. If you did not subscribe till now, then please do subscribe to learn and grow community for regular updates. If this video is informative, then please like this video, comment on video, and don't forget to share. Thank you for watching.